Hello. So in this video, we are interested in finding the value of A, D, and R simultaneously. So there will be cases like in these few examples that we are going to do together where you will be given a statement, and from this statement you'll be asked to determine the series. So they are saying an arithmetic sequence, or it could be a series, it doesn't matter, has a third term equal to 13 and eighth term equals to 38. Now for arithmetic sequences, Tn equals to a plus n minus 1 times d. So if they are saying it's the third term, that's T3 equals to a plus 2d, because if you say n, which is 3 minus 1 is 2, so it's 2d. They are telling us that the third term is 13, so this is the first equation. And then they also tell us that the eighth, T8, which is a plus 7d, they tell us it's 38. And this is the second equation. Now we can say equation 2 minus equation 1. So that would be 38 minus 13. So that will give us 25 equals 2. A minus A is 0. 7d minus 2d is 5d. And if you divide by 5 on both sides, d is equal to 5. And then we can substitute d in either of the equations. So if we substitute in the first, so that will be 5. This is 10, so 13 minus 10 equals to a, and a is equal to 3. So writing our sequence, we can then say the first term is 3. The second term, remember it's a plus the difference, so that is 8. The third term, they told us in the statement, is 13. So that is your sequence. In the second example, I like it because it's actually interesting because they integrate the idea of series, the idea of sums. So they are saying if the seventh term of an arithmetic series is 16, so T7, that is a plus 6d. Now they are telling us this is 16, so that's a plus 6d. That is first equation. Then they tell us that the sum of the first terms is 115. So for an arithmetic series, Sn equals to n over 2 into 2a plus n minus 1 times d. However, you can think about this in a different way. So you can think about it in a slightly different approach. So this approach is basically saying, well, you still have 2a, and then, okay, let's write it first, n minus 1 times d. So sum of 10 will be 10 over 2 into 2a. So 10 minus 1, that's 9d. Right. So this sum of 10 is 115. 10 divided by 2 is 5. This is 2a plus 9d. So this is 115. 5 times 2, that's 10a. 5 times 9, that's 45d. This is the second equation. Now you can manipulate, let's use red. You can manipulate the first equation and write it as a equals to 16 minus 6d to form a new equation 3. And if you substitute this equation 3 in the second equation, you'll have 115 equals to 10a, but we know a in terms of d is 16 minus 6d plus 45d. So it's only just a matter of simplifying. So this is 115, and if we simplify this, 10 times 16 is 160. 10 times 6 is minus 60d plus 45d. Transpose this 160, so that's minus 45. Minus 60 plus 45, that's minus 15d. Divide by minus 15 on both sides and you get d equals to 3. And then let's use a different color, maybe green. Now we know d. We can then substitute back in equation 3. So a is equal to 16 minus 6 and d is 3. So a, you can plug this in your calculator. This would be minus 2. The third and final example in this situation is a different one because now it's a geometric sequence. Let us get back to black. Right. So in a geometric sequence, the sixth term is 8. So Tn for a geometric is AR to the power n minus 1. So T6 is AR to the power 5. And they tell us this is 8 AR to the power 5, and this is the first equation. And then they also tell us that the 12th term is 512. So T12 is AR to the power 11. So that's 512 equals to AR to the power 11. And this is our second equation. And if we say equation 2 divided by equation 1, so 512 divided by 8, that will give us 64 equals to a divided by a is 1, r to the power 11 divided by r to the power 5 is r to the power 6. Now it's very tempting to say we change 64 and say what base raised to power 6 will give us 64, which will be 2. But I urge you perhaps to take the square root on both sides, or the sixth root. Because 6 is an even root, your answer for r will be plus or minus 2 because it's an even root. So this means we have two possible sequences in this particular case. So the first one is where r is positive 2. So let's get our value of a. So a, we can use any. So let's say 8 equals to a r to power 5. So 8 equals to a 2 to power 5. And then we divide on both sides by 2 to power 5. and we'll get our first value, which will be 1 over 4. But if we substitute minus 2 to power 5, so our A will be minus 1 over 4. So let us write these two sequences with different colors. So the first one would be 1 over 4. To get to the next term, you multiply by positive 2, so that would be half. And then you multiply by 2, that would be 1. For the other sequence in green, where our A is minus 4 and our R is minus 2, the first term will be minus 4. If you multiply by minus 2, so that will be positive half. But if you multiply by minus 2 again, it will be minus 1. So in this particular case, it's very important to remember that there are two possibilities, because 6 is an even number, which means we are looking for an even root. And an even root has two possibilities.